Hi everyone, October the 8th. All right. So I took some time to go through the two other methods, which is this is just top down, but with a different kind of idea. And also this is the with prefix sum with also different idea. So we got these. I'm not gonna go through them, but the ideal is I will keep this one, maybe somewhere here, right? So once we solve all these, we come back to this. I really want to solve this one more time. I think it's really important to practice it multiple times. But we have different problem today, difficult one as well. Let's hope we have a better shot at this one. All right, let's see what this one is about. Given two arrays, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. The maximum dot product between non-empty subsequences of nums1 and nums2. A subsequence is, we know, something we just delete, all right? By deleting some non-empty subsequence without disturbing. So 2, 3, 5 subsequence, yeah, we know what subsequence is. So for this, we take nums1, that's actually a very interesting question. A very interesting question. So because it's a dot product, right? It's a dot product. Yeah, it has to be the same length. Basically is we take some value from nums1, we take some value from nums2, and we want to find their dot product and to maximize them. All right, so earlier today when we were solving the other problem, we made a mistake of going through the mathematic kind of route, and then it's not working. And this one, just judge based on this, we immediately know it's not going to be mathematics. It's going to be DP. So the idea is, how do we find the state so we can do the DP on this? Exactly, like how DP will work on this. That's a very good question, right? So basically, what we want to say is we want to find some 500. That's way too big. Okay, that's way too big for bit mask, right? So we're not gonna do that. But how are we gonna choose? Right? We're gonna choose some. We're gonna choose some, right? And then multiply, 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 and find the sum, right? So what is the state? Well, what we can do is, usually in this, we can say that we have an I here, we have a J here, okay? So we say we will find the max product, okay, all the way to I, and the max product all the way to J, right? So we have all the way to I, all the way to J. We know all combinations of max product. Now we have the current one. Now we can say I minus 1, J minus 1, right? So we have the current one, okay? Current I, current J. So it's 5 and minus 6. Now what we want to ask is, once we include this, right, I want to find the maximum. So we can say, well, it's going to be maximum, right? So we can say, okay, it will be the max. If we want to include these two, let them pair. The max will be dp I minus 1, j minus 1, right? Plus nums 1 I times nums 2 j, right? That's one possibility. And another possibility is that we don't want them to pair, okay? We don't want this to, so this need to pair with any one of the previous. We just pair, 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 pair. Once we find a pair, then it will be, right? Or we pair this, this, this. So it will be like this, right? Either this, and then we need to go have to pair with all of them. Well, honestly, not all of them, because if it's negative, we don't have to pair. It's gonna be actually, we don't know. We don't know. So we have to pair with all of them, right? This one would pair all of them. So shall be 4, you know, we can call JJ, right, in range. So if we pair with this, oh, what if we pair with the first one? It's 0, right? It's just going to be this and this. So this one all the way to J, right? So dp ij, we can say shall equal to maximum, right? Whatever. And this is going to be nums I, 1i times nums 2 jj. So we say we pair this and we plus dp I minus 1 jj minus 1. Ooh, jj. So we have to have another one at the front because this could be 0. Okay, so we have another one at the front. Right? So this will be 0. So go through that, and we have to go through. Okay, so this is kind of my idea at the moment. Do you want to use JavaScript for this? Yeah, let's JavaScript this. We might be able to do it, JavaScript. I don't think this will be too complicated. Even no, not JavaScript. What the hell are you talking about? I'm saying, can we Java it? Okay, so we can say int. I don't really need to. Int. Okay, dp new int. You can say nums 1 $length plus 1. Nums 2 $length plus 1. Okay. Then we say for int I equal to 0, I smaller than nums 1, then length I plus plus. Do we have edge case? We actually do have edge case. When I is 0 and j is 0, actually, this one should be from 1 to this plus 1, right? Yeah, we can say smaller equal to, right? Because this ij is relative to the dp. That's kind of what I want. The number, right? I will be the number included. So if we include only 1 and only 1, this is just their value. And I think should be fine, right? And then we'll say for j, int j equal to 1, j smaller equal to nums 2 dot length j plus plus, right? So what I want to find out is int ij. Okay, so int ij, not int ij, dpij. Okay, initially shall equal to math.maximum dpij and dpi minus 1 j minus 1 plus nums 1 I minus 1 times nums 2 j minus 1. That's the initial condition, right? Then we say for int jj equal to 1, jj smaller than j. Ooh, I can do that. Then this one will include, right? Yeah, it will be included. Then jj plus plus. We say dp ij shall equal to math.max dpij and dp something something plus nums something times nums2 something. All right, so what's this? I doesn't change, right? I say I does not change. Hold on, let me go back here. So we have I, we want an ij. So we want to know if we shall ignore this, right? If we, well, basically we will take this, take this, take this, take this all the way to the front. Right? We'll take I, we're gonna match everybody. So we'll match everybody, or we'll match everybody, or we don't match. We don't use this. That's another one. All right, that's another one. We can choose not to use it, which means I think it'll be better to start with this. Okay, this is our starting position, as we just ignore. All right, we say ignore nums1 I and nums2j. We ignore it. We don't use, do not use this or this, right? That's one. Or if we want to use it, right? Know that I is an index of dp, which is one more than indexing nums1. Okay. Same as I, j is one more than indexing nums2. So yeah, that's that. And then now we can indexing from this. So this will say we will use, right? This is use nums I minus 1 to pair with all possible nums2, right? So this is I minus 1, right? I minus 1, because we want to pair this with everybody. Once we pair, should add with I minus 1. So I minus 1 here is going to be, because we pair with jj, so it should be jj minus 1, right? Jj minus 1, and we'll pair here nums1 with I minus 1, nums2 will be jj, right? That's jj, so that's 1. And we can do exactly the same thing, right? We can do exactly the same thing, but we'll do I. Okay, so I smaller equal to I plus plus. So it's nums1, so it's nums2 j minus 1 to pair all possible nums1s. So again, this will equal to maximum this. Now this is going to be I minus 1. Okay, I minus 1 to j minus 1, and nums1 is going to be I minus 1. This is going to be j minus 1. All right, so we go through all of these, right? All of these. And in fact, because I already considered I and j, so I don't have to go to I, so I can just do smaller than I. We can save one, right? We can save one. So once this is done, we have dpij, and it'll just keep going. And at the end, we still will return dp something something. So I think that should return nums1 $length, nums2 $length. Let's see if this is correct. Almost. I think the initial value, yeah, it could be negative. So initial value shall be slightly different. How do I initialize it? So now I go to 0, which means the negative values are not considered. So I shall get this is I can set this to, which I think I should, initializing, right? Initialize for now int I equal to 0, I smaller than nums1 $length, I plus plus. Then what we can do is dp I 0. We set it to integer dot minimum value. And I will do the same thing, okay, for j. Okay, so j smaller than nums2 j plus plus 0j, okay? And then we'll do dp. Okay, so with this change, let's see if we have better luck. I think that's too small. Let's do minus. So what will be the smallest b? I don't know. That shall be the smallest. 1, 2, 3, 4, 5, 6, 7, 8. That shall be the smallest. Right? That is the smallest. Is because each one, the smallest each one can get is 1 million. And a 1 million times 500. So that's the smallest you can get. Ooh. It's not what I had expected. I think something is not right. Because I start from 1. That's why I said everything is 0, right? Everything that's 0 will have a negative value. So if everything is 0 has a negative value, yeah, so this will be a negative value. And this will be a negative value. Ooh. Interesting. So what I think is I cannot do it that way. I simply cannot. I think I need to set. You know what? I think I did it wrong. Here's what I think. I think this is not necessary. And I think we shall do it here. Math dot maximum dpij and this. But if you do that, we say we do not use the current. So it shall equal to the previous one. Yeah, it shall equal to the previous one. Right? We don't do that. It shall equal to the previous one. And then, but this gives you wrong answer because the negative cannot be identified. So this will be 0, right? And then this will be 0. And the current will give you -1. How do I reconcile those two things? If I do not use, I think the problem is just with this initial value. Initial value shall be 0, right? We shall go through all of this, then give you a value, right? And that value but it also requires, it does require this, right? It does require this part because I can choose not to use the current pair, right? If you do not use the current pair, but you need a first pair, right? However, we need to have a first pair. And the first pair exists as a DP11. That is the first pair. You just have to. There's no going away from that. You have to have a first pair. DP11. Alright? So what I think, maybe we can do this. DP11 is a determined value. So nums 1, 0, right? Times nums 2, 0. There's no going away. Okay. Now we do this. Okay. And of course we say if I is equal to 1 and j is equal to 1. In this case, we just continue. Don't do it. Continue. Continue. Otherwise, we keep going. That makes sense. Let's try this. We got a wrong answer. Output is 0. So it's a little bit more complicated. I think, yeah, that's actually not right. Okay, so let's try another one. We will initialize everything, but I is equal to 1, okay, and this we'll go through, we say this is a j, so j is 1. We go through everything, okay, we go through everything to fit j as 1. Oh, so in this case, why do we even handle it differently? Maybe I can just go with this, right? You can say, yeah, I start from 0 all the way to the end, and j is just 0. So this shall equal to, like, all the way to here, all the way to here. So there's can only have 1. So we just multiply, right? Find the max one so far. Huh. Hold on. This requires some further thought. Let me go through this. If, right? The maximum so far. So what I want to find is up to here with this. What is the maximum, right? So if I choose, 0, 0, I have no clue why this is so hard to reason. Right? I use this as example. So it'll be 4 rows, okay? 1, 2, 3, and 4. Right, 4 rows and 5 columns. Okay, so we'll have -5, -1, -2, 3, 3, 5, and 5. So what I'm saying is these are the actual thing, okay? So we say if as this, that shall be -15, right? We say if I is equal to 1, so only 1, j, I say this is -15. And this is -15. Up way to here is still -15. This should be -15, right? And we say, given an I and j, what we need to find is, shall you go to the previous one, which is here, right? The previous one. And that's, do not use the current one. Or the previous one, or use the current one. So if we say this is negative infinity, so will we use a current one? Or I say j is equal to 1 all the way to the current j shall be the maximum of this, whatever we have, and dp of this plus whatever we have. How is that not right? Exactly. How is that not right? Right? Then we move on. Let's J move on. And these are all negative infinity. Right? And if in here, in J I have two J's to go through. Right? So I say, I'll take this one. Yeah, I don't understand why the initial implementation is not right. I go through every single one, right? So you choose the current one. Right, you choose the current one. Yeah, that's why. Because of this negative infinity is actually making things complicated. That's why I say I don't do this. I'll just handle the first row and the first column. And now we start from here and everybody is included. Yeah, so let's do that. But we need a little bit. So this one needs to change. And that's what I say. I don't want this. Okay, I don't want this. And then this is the I, right? So but if we really do that, no, we do have to. So dp 0, okay? 0 shall equal to nums 1 0 times nums 2 0, okay? And then we say from 1 to this dp I 0. Oh, I do it already. So it'll be math dot max dp I 0. So J we take this dpi. So up to, so dpi minus 1 0 and nums 1 I times nums 2 0. So this will be the same. We go from 1 all the way to the end. This shall equal to math dot max. This is going to be dp 0. All right, j minus 1. No, j. This is I. No. This is j minus 1 previous, and then this is a current. All right, current. So with that, then we can do this. We don't touch all the zeros. Then we can say, okay, we don't want to use I and j. Right? Then we can actually do math.max this or dpi minus j minus 1 j minus 1 plus dp I times dpj. Okay? You just use the current, dpi, not dpi. Alright, this is nums 2j. Right, that's the first one. And then we'll go through everything. All right, we go through everything. JJ can start from J. We don't touch the J, and we have the current I. So we go through everything, and then we try to use, right, the current JJ and the current I, and then we try the previous. And this one is the same. Okay, so we have a new model now. Actually, this should be -1. Let's see. Do we have, do we make more sense now? We're not accurate now. That is bonkers. Absolutely bonkers. Oh, because this has to go from I do 0, 0, and I equals 1. And J is 0. Yeah, because I only can take 1. You find the maximum one. It's got a -9. That is bonkers. Right, I handle this. So now we start from 1, 1, 1, right? Now we start from 1 and 1. So J is this, right? So this is -15, and I equal to 1 to the end. This shall equal to maximum I -1 and a current, so it'll be -3. So that should be -3. This shall be -15, right? And now we say well, I is this, so the maximum will be this plus this. Also, this should be at the moment, right, is -15. Then we start is -15. And then we say JJ is equal to 1. So we say I will keep the same. Okay, we'll keep the same I. But J, we're going to go from this, right? So it should be maximum of this and JJ equal to 1. JJ equal to 1. That doesn't make any sense. Because I need to go, right? I need to go all the way to, I need to go there, right? I need to go to 0. Let me think again. Maximum. Yeah, if JJ is 1, that means when I'm doing this, oh, I can only also just take, I don't think this is the answer. The answer shall be either I don't take the current, I take the current with the previous, or I take the current itself. Right? And for everyone, we have the same idea. We can either take it. We can take it. We can take the current. Just the current. Because we want to find a maximum, right? We want to find a maximum. So, if we want to find a maximum, actually, hold on. What if I just do this again? Math.max. That is just one possibility. There's another possibility, right? Is just this. The nums 1i times nums 2jj. That's the other possibility. We just take that. You know? We just take the current. We don't care about all the previous. We just take the current. Current I and current from nums 1 and nums 2. That's it. We just take that. So we can either take that plus the previous one, or don't take that. Right? And this, well, I mean, this is just by itself. Let's give this one a shot. This shouldn't be that hard. Ah, jeez. Ugh, how come it's still not right? It's actually getting worse, because I got the first, ugh. These are awful. These are awful. Okay, so maybe I still need this. You know, we do that. Oh, I haven't changed the second part. Dude. Can't believe it. I. That's right? Nope. That is. Oh, we got 3 correct. Now we have. Man. Oh man. What the hell? I don't understand. And I think I don't have to do this. Oh, dude, you'd have to. Shoot, I do have to initialize this. Otherwise, this will be 0. Okay, that makes sense. That makes sense. I don't know, I'm just trying different things. Yeah, it's not gonna be one. It's not gonna work. All right, so we have to draw that out. This one works. Okay, this one works. The one that doesn't work is the second test case, which is 3 minus 2 2 minus 6 and then minus 7. So this will be 6 6 21, right? You're kidding me. You're kidding me. Hold a second. Nums 1. Oh yeah, it is 21. And this is minus 4. 12 and 12. That got 18? What the hell does 18 come from? No, these two doesn't exist. My bad. These two doesn't exist. I did 0 0. Okay. And then 1. I minus 1. Oh, my bad. This is not sitting. That's not. Come on. It should be 6. Right? So that's 1 1. We start from 1 1, right? So that equal to maximum of this 6, or we take the current one. So this gives you 18. Right? And then I say for JJ equal to 1. Because I is 1. Okay? I is 1. So JJ equal to 1, JJ smaller than 1. We don't do anything. Because we are at 1. JJ has smaller, so we don't do anything. I so we don't do anything. So that's 18. So here, okay. Oh, so I want to do this. You say either this. This is nums 1, nums 2, right? We want to add, this is I, this is J. Shall be, if I don't take Okay, if I take ij, right, that's this plus this. If I don't take ij, that's where we got wrong. Okay, that's where we got wrong. If I take ij, right, if we take ij, that's dpi minus 1, j minus 1, plus, nums 1i times nums 2j. That's correct. If I do not take ij, okay, that shall be dp I minus 1j or dp ij minus 1. So it should be the maximum of these three values, right? And then for each one, I do, take everything. And when you take everything, it's going to be maximum of this and previous plus the current. So we want a maximum of that. So I do think the only thing we need to change is, but when you take the current, so not necessarily you have to take the previous, right? It's not necessarily then to take the previous. So what we can do, okay, what we can do is we'll set, dpij. We set dpij will equal to nums 1i times nums 2j. We set dpij into this. Okay, we set it into this. And then we say dpij will equal to the maximum. That is stupid. Okay, that is stupid. So what we want to do is we'll take this, we'll do math.max this or this. Right? So either I add the previous or I take myself. And this shall be this dpi j minus 1. That's the original value. And then we go through each one of them, right? We go through each one of them. And this is what I'm going to take. Okay, I'll take every single one of them. And that's how we take, right? We'll take it. So this is just, yeah, so that's what we have to do. Or either take the maximum of, just current, or the current plus the previous one. Because we don't know. We don't want to know, basically. We don't want to know. So I want to make a little bit change to this. I think it'll make more sense if I put this one here. That will make more sense, right? Actually, let me just, I think it'll be easier to code it here. This is initialization, and after initialization, I'll do the current. Okay, this is the current. And then this will use that, and this will be using the other one. Okay, so this will be using the other one. I will do exactly the same thing. I can cancel this. Put you here. Math.max. Okay. Okay. If you say so. Right. Oh, this is kind of the new idea put together. It's correct. That is correct. That is correct. Okay? We got this one. Well, we know immediately that this is DP. And it's similar to finding longest common subsequence. Okay? Similar to finding longest common subsequence. Now my question is, can this be even simplified? What if you think about it? This is not good. Okay, not good. Because the runtime is OM squared n squared. That's the current runtime. Which is why we have pretty bad runtime. So I want to see if it's possible that we make this one better. Oh, definitely it's possible, because I am pretty confident that this one, it's 8, we're going to be Java. I'm pretty confident that this one shall be OMN. We just need to figure out a way to not do this one more time, right? So how can we reduce these two? But we have to go compare them one by one. So what are we exactly doing? We're going through everything, right? What if we know? So yeah, we're comparing the maximum of dpi minus 1, jj minus 1 plus this and this value, right? So we're comparing that. So dp this, if let's say we have for I, basically for I and j, right? For I and j, I want to know, and it's go through all of them, right? So just given an I, okay? So given an I want to compare to this, 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 this. And every time we compare, I want to compare this value and so can we, can we do some prefix? Because it's from JJ is from 1 to some value, right? 1 to some value. So 1 to some value, I want to find out the maximum of, all of those. The maximum of this plus that. Okay. If I've found it, right? If I've found it, the next time, right? The next time, then we don't have to go through the whole thing again. So what I'm saying is, we have I and j, right? We say I take ij. If I take ij, I'll do this. If I don't take ij, are you telling me that we don't need to do this? Is that what you're telling me? Is that what you're telling me? That would be absolutely ridiculous. Then this is exactly LCS. Oh yeah, this is exactly LCS. Holy crap. This is exactly LCS. I don't even know what to say. I feel so stupid. You did this. It's already been done. All right. LCS it is. Solved it. Oh. Space optimized. Yeah. You can use that's 1, 2, 3. 3 values. 4. Yeah, I'm not gonna go through this. We got this, okay? We got this, and that's it for this one. All right, let's solve one more to see if we have time. Can we do it fast? A pull limit. Return an asynchronous function. It should return a promise that resolves when all the input function resolves. Maximum number of promise that can be pending at once. Execution as many functions as possible and continue executing new functions when old promises resolve. Holy crap. Execute this, then this, then this. When the last promise resolves, should also resolve. To show 2 functions. When either of the 2 functions resolve, a third should be executed, and so on, until there are no functions left. Okay, so they have promise dot all. No. I think it's promise dot race still. All is when all the promise fulfills. No, I don't want. I want the first one that I return. But you are canceling the others? Let's take a look. So we have 3, right? N equal to 2. So we'll do these 2. T equals 300. The first one gets resolved, and the third is executed. Pull size is 2. 400. The second got resolved. Yeah, and there's nothing left. Pull size is 1. Yep. Interesting. How can we make sure that everybody is one is done. Does poll has what I'm thinking is we use raise, and when the first one gets resolved, we will we add a new one in. But what if two resolve at the same time? Yeah, if it resolve at the same time, then you should put two in. Does this one tell you? So when this comes out, what happened to P1? Good question. What happened to P1? Good question. What happened to the losing one? That's my question, right? So it keeps running. This is exactly the behavior I like. I want this behavior. But what I want to know is how can I add new ones into it? If I want to add a new one into it, so let's say one of them is done. how do I know? Well, I just add. How do I know how many I can add? That's the question. Is this possible? You know what? This is a good answer. You create a promise for each of the elements. It's a new promise. That's not my question. Holy crap, that is your question. You remove one, right? You just need to add one. Huh. Can we keep racing it? Can we race it? No, we do this. Okay. Interesting. Has to be splice. Shoot. Has to be splice. Yes. So I just need to find it. I just need to find who gets returned. But each one I add, I can add at the end. But how do I know which one need to be popped? Yeah, I need to remove it. That's the thing. I need to remove it. If I have, because all I need to know is the index, right? That's all we need to know is the index. Because I can use that to an auxiliary. I have an auxiliary array, okay? And when we do that, we can have an auxiliary array, right? And then we can say runner equals this. And we can say runner is going to be wrapper, right? Async wrapper shall be a P, a promise, right? And some key, okay? Await P. So I'll pass a promise. And then return result and key. This is a wrapper. So the auxiliary we can do, Alice, Bob, Claire. Runner is going to be wrapper, runner, Alice, right? Runner, Alice, Alice, Bob, Claire. We can even do this. Okay. Now, what we shall do here is key. Yeah, const this key promise dot race runner. Okay, then runner dot splice we can say display something. What is a something? It's aux dot find index. Okay. Index change. Index change. So that's not right. What if the auxiliary is a map? You thought about that? Let's do a map. Okay. If we do a map, and then we say this is equal to this. Okay. This is equal to this. Okay. And we can say while map.length. No, map doesn't have length. Object no keys. Map.length is larger than 0. We say okay. We say rest equal to this. Then map dot remove. Okay. And this is going to be object dot values. Then map will remove this. Do it again. Do it again. Do it again until we're done. Let rest. Current. And rest equal to current. And the idea will return rest. I can say console.log. No. Run dot then I forgot what's the syntax for this. Delete. Actually, I'm not sure. Oh, this is actually a good idea. I'm basically using that idea. I forgot it. JavaScript object remove key. Oh, delete. That is interesting. Alice starts, Bob starts, Claire starts. Claire finished first, and then Alice, and then Bob. And the return is something I did not expect. This is a delta. In name. Oh, this is the delta. That's the one. This is the answer. This is the answer. I'm gonna do it. Okay. So we have all these promises, right? We have all these promises. What we're gonna do? Functions is a list of functions, right? Yeah, it's a list of functions. So what we want to do is constant map equal to we need a index. Okay, so it should be object dot from entries functions dot slice. I'm not sure. Slice is 0 to n. Is that how it goes? I'm not 100% sure. Let's go to console. Zero. Let's say we go 3, so it should be 1 to 3. Yep. So we slice n. Okay. Then the map. Map what? F I to the wrapper. Const wrapper. I can just copy and paste this. I like this wrapper. Okay, that's a wrapper. And then I'm going to return promise function call. I. That's actually not right. This is just a value. So what I need is turn this into I remember this is how you build a map. Okay. Okay. Then we can say let index, the new index shall be n, starting from n. Okay. Then we say while we do a run. Okay. And then we need to add things to it. A map index shall equal to a wrapper functions index index, get index plus plus. Of course, if index is smaller than functions.length, we add more index to it. Now we return run. Okay, so we need to return a function. No, we need to return this. -1. Why is it not right? I resolved the first two, but I failed to resolve the last one. Error. Callback argument must be of type function. Received undefined. Received undefined. Invalid argument type. Oh, which one? Alright, let's see how the map goes. That is bonkers. That is bonkers, man. You're not supposed to be like that. Something is wrong here. Map. That's, you know, first. Yeah, it doesn't make sense. Hold on, let me put more time into it. promise. This returns a promise. Maybe. Maybe. I just pass a function. Call the function inside. You gotta be kidding me. Seriously, you gotta be kidding me. Oh. They got this one wrong. Shoot. Shoot. That's still not right. That's still not right. It's not supposed to be this way. This is a new promise, right? We set timeout 3,000 milliseconds, supposedly. And then you call this function. They don't understand. Mapping, these are the promises, right? These are the promise. Why are these printed out immediately? It doesn't make any sense. Yeah, basically I have an f, right, the function. I'll return the result and the k. This is we do that. So we wait for the values of the map. So it will give me this and this. It was working earlier. I don't know what happened. Yeah, this is returning a promise. No, this is returning a promise. And this wrapper is returning a promise, right? So I'll wait on erase the values. The callback must be of type function received undefined. Hey, what the hell are you talking about? Which one? I'm just trying different things, just trying to see like what the hell happened here. We pass a function, right? I'm not await on the wrapper, and it's not set timeout. That's the thing. That's the thing. Just confuses me. It didn't really set timeout. Oh, this is a resolve. He did not resolve it. Oh, shoot. Resolve what? Oh, yeah. Should be resolve. My bad. I thought that's a result. It's not a result, it's a resolve. Right? And then we can, now I don't need to do it here, I'll do it here. Okay. Yes. Right? So in that case, I can do 2. So someone gets out first, shall be full or bar. Bar. Low. Yeah. Okay. Try it again. Try again. Yes. I think this is right. Okay, not really good runtime, but it's good enough. It's good enough. All right, I'm gonna call it for a day. Actually, don't do it here. Use the trick from. Ugh. Turn off. I need both. I need both. So this is the theory, right? Okay, use the theory from this, which states that the promise raised will continue to be executed. Use the trick from here. Now this one. Okay, use a trick from this to identify which promise is the winner, right? Is the winner of the race. Then we can remove the winner from the current pool and add a new one to the pool. Yep, that will be it. Okay, let's take a look. Good question. Promise.all array.shift. All right, I'll read this later. Let's just call it a day. I'll see you guys tomorrow.